Hey guys, this is Mrs. Cutting, and this video is going to go over a recap of the last several lessons that we've done. If I get to a summary and you have not highlighted it yet, please do that during this video. Some of my classes are at different places, so hopefully this will catch us all up. Okay, so in Unit 2, the very first way that we were representing ratios was with diagrams. So we had like green paint and white paint, and we were drawing the squares, and that was great as a starting point. Except for if we had to draw a whole bunch of batches, well then that became kind of an issue because there was like, you know, a lot to draw. And so then we went into, let me get there. There we go, the double number line. So the double number line was a way that we could show several batches all at one time without having to draw out all these squares. And the double number line was working out pretty well for us. Until on Friday, when, I'm skipping around a lot, sorry. On Friday, as you're due now, you looked at this part, which is page 61. So we drew a double number line, answered one question about it, and then it asked if someone uses 400 liters of orange juice or 455 liters of soda water. That wasn't on our double number line. Our double number line went out to about 50. So if I wanted to make a double number line, it would have to be like super duper long, and I would have to draw all those tick marks, and I would have to label all those lines, and that would just be a whole lot of work. So on Friday, we introduced a different way to represent those equivalent ratios, and that is through a table. So on Friday, we looked at, this gave us a recipe for trail mix, which uses 7 ounces of almonds and 5 ounces of raisins. So they gave us the 7 and the 5, and then we had to find how many ounces of raisins for 28 ounces of almonds. So we looked at that and we said, well, it is just 7 times 4 gives us 28. So over here we can do 5 times 4, which gives us 20. And that was how we found it. So we didn't have to draw a whole diagram. We didn't have to draw a double number line and have it go out forever, like 250. That would be kind of a pain. But we're still using this idea of equivalent ratios. For this ratio to be equivalent to this one, I need to multiply both of those by the same thing. So then to get to 10, we can do 5 times 2. And then over here we can do 7 times 2, which gives us 14. To get to 3.5, that is half of 7. So we could do 7 divided by 2 and 5 divided by 2, and that would give us 2.5. So we can look at any of these rows to help us get these other numbers, but whatever we do to one side of the table, we have to do to the other side of the table. Okay, so then also on Friday, nope, wrong page. Yeah, wrong page. Still wrong page. There we go. Okay, so then also on Friday we looked at this taco problem. Noah bought 4 tacos and paid $6. And this time the table was blank. 4 tacos, $6, and we had to find $15. And people did this a whole bunch of different ways. Some people found the price for 1 taco. Some people found 12 tacos and $12 and $3 and added that together. And we saw a whole bunch of different strategies, a whole bunch of different ways of breaking it down. And because the table was blank, it was up to each person how they wanted to do that. Okay, so then there was also this table, and we talked about this in some of my classes and not in all of them on Friday. So now we have Lynn is paid $90 for 5 hours of work. So we have her 90 and her 5. And then we wanted to know how much she would get paid for 8 hours of work. Well, the most efficient or the fastest way to get there is to figure out how much she gets paid for 1 hour of work and then multiply it by 8. And this row of how much she gets paid for 1 hour is extremely useful to us because then we can multiply this by anything. If I suddenly asked you, well, how much would she get paid for 4,292 hours? Well, we could do times 4,000, I don't remember what number I just said, 4,927. I know that wasn't what I just said. Huh. And then over here I could do 18 times that same number and figure out how much money she made. And then in the table, it's kind of blurry on my screen, but they found this by multiplying by 1/5. And this multiplying by 1/5 is the same as dividing by 5. We saw that earlier in the week with our problem strings, that if we were to divide by 3 or multiply by 1/3, it would give us the same thing. Okay, so one more thing about this table. So we started with the avocado problem. Let me find that again. On Tuesday, we had 8 avocados cost $4, and I wrote it out like this. 8 avocados cost $4, and then we needed to figure out how much do 16 avocados cost, so I wrote out 16, and I was already sick of writing the word avocado, so I wrote 16 avos cost, and then we calculated that it was $8. The table is a much faster way of writing all this out because I don't have to write this every single time. Okay, so I think I did the lesson 8 summary with everyone, but I'm not sure, so I'm going to start there. So lesson 8 summary. The unit price is the price for one thing. The price of one ticket, one slice of pizza, 1 kilogram of peaches. So if 4 movie tickets cost $28, then the unit price would be the cost per ticket, how much it costs, how many dollars for one ticket. And we can create a double number line to find the unit price. So here's the double number line. It showed the 4 tickets and the $28, and then we can work our way backwards to figure out how many dollars for one ticket. So we can do it with the double number line. We can also divide. $28 divided by the 4 tickets would be $7 per ticket, or by multiplying, finding 1/4 of 28, which is also 7. Okay, this is on page 48, so if you have not highlighted that yet, please do it now and pause me for a second while you get there. So then lesson 9 summary, this is on page 53. Suppose a train traveled 100 meters in 5 seconds at a constant speed. To find its speed in meters per second, we can create a double number line. So this double number line shows that the train's speed was 20 meters per second. We can also find the speed by dividing again. We can do 100 divided by the 5 seconds, give us 20 meters per second. Once we know the speed in meters per second, many questions about the situation become simpler to answer because we can multiply the amount of time by the speed to get the distance. So if we wanted to know how far it would go in 30 seconds, we could do this 20 seconds, which is how far it goes in, or the 20 meters, times the 30 seconds, and then multiply this times the 30, and that would get us 600. Okay, so then lesson 10 we skipped, so we're going to skip right past that. So then we're on to lesson 11. So the summary for lesson 11 is on page 63. And here is where they first introduce a table. So a table is a way to organize information. Each horizontal set of entries is called a row, so these are all the rows, and each vertical set of entries is called a column. A table can be used to represent a collection of equivalent ratios. So then they showed us a double number line for this situation and a table for this situation. And all of these are equivalent ratios. They're all equivalent to this 2 to 3 because this row is just 2 to 3 times 2 on both sides. Then this one is times 3 times 4 times 5. I'm not going to label all that. Okay, so then one last summary. Lesson 12 summary, which is on page 69. Finding a row containing a 1 is often a good way to work with tables of equivalent ratios. For example, the price for 4 pounds of granola is $5. At that rate, what would be the price for 62 pounds of granola? Okay, so we're at 4 pounds. We want to get up to 62. So the first way they did it, which they're saying is less efficient, so it's going to be more work, take more time. They did times 2, times 2, times 2, all the way up until they got to 64, which was close but not quite what they wanted. And then they subtracted 2 pounds, and on this side they subtracted the price of 2 pounds, so they subtracted $2.50. Now that's fine, but that's kind of a lot of work. So then the more efficient strategy is to go from 4 down to 1, and they did that by finding 1/4 of 4 and then 1/4 of the $5. So this gave them $1.25, and then they just multiplied it by 62. So much fewer steps here. If you prefer this way, because this is easier for you to mathematize and you can kind of do this by reasoning your way through it more, that's perfectly fine too. Notice how the more efficient approach starts by finding the price for 1 pound of granola. And then one more little tidbit. Remember that dividing by a whole number is the same as multiplying by a unit fraction. So in this example, we can divide by 4 or multiply by 1/4 to find that price for 1. All right, this was a lot longer than I expected it to be. Thanks for listening. Thanks for sticking with me. Next, you have some practice problems to do in your workbook, and I will see you all tomorrow.